talk about something. Yeah.
Hey, yeah, Coffee Compiler Club. Looks like people are going to drift in like they've been for the past month. So short conversation, a short count of people, but we're going to talk build systems because I've been working with a great old, I'll be semi-polite and say fanboy, and I'm hating it. And there's no great old fanboy on here, so we don't get a fair and unbiased presentation of the different options. However, I got somebody here. Theodore's been using Google's Bazel. Is that what you said?
Yeah, Bazel, yeah, the open source version of Blaze.
Open source. Yeah, right. Okay. And then
Yeah.
and then how's that going?
And so I'm not actually using 100%. So I was using something called Pants, which is a Twitter built kind of sort of replica of the system before Bazel become open source. So so far it's working good. The build structure are in build files, so it's uh, it's similar to layout to Maven, but so far it's working good. But I
Okay.
don't hate it. I don't hate it too much. Mm.
You don't hate it too much. That's a good start.
Yeah, yeah.
And then the usual thing is like, is it stable? Is it fast? Does it seem to have any fails where you fail to get things built or whatever? Is there any up or down that seems obvious to talk about? Or you're just gonna say, yeah, it worked fine, and then just walk away.
Yeah. So what do you expect? To
I,
not get in your way. So
fine.
that's a build. I'm actually pretty much a fan of a build system, build a source inside your program. So the
Yeah,
build is part of your programming
I have done
language.
that several times in my life, and it's always worked out well.
So I believe that's the way to go for a future build system. So
Geez. Well, that says I should go try that now. All right, fun.
something to work from.
Something there. So, York, what are you using for a build? You have your personal project in your house thing for Inco, but is there an official Inco?
I mean, the build system is just in the compiler. It's fairly straightforward because
So it's built into the language.
uh, well, so my build system basically there's no support for like compiling C files from source and all that stuff. So
Okay.
it's purely targeting Inco source code, and that
Okay.
makes
So
the process
like
fairly.
Java C, he finds all the other parts from the starting file you gave him and sorts it
Yeah,
out.
I suppose so. It's basically it finds all the source files. Okay, wait, I have to take a step back. So, when you build a project, you just run like inco build, for example. There's no make, whatever. Um, Essentially, what it does, it looks for your main file. If you're building a binary that's currently called main.inco. And in the future, I'll probably change that so that it's going to be in a different directory, but with names, so that the executable name is derived from the source file. Because
Yeah.
right now, if you have like a file,
Okay.
you have like your directory called src for your source files. There's a file in there called main.inco, and when you just run inco build, it will spit out a file called main.
Gotcha.
But it isn't really useful because most people want to have
They'll
the
rename
actual
it. Yeah.
program name.
Right.
So I'm planning on changing that, where basically my thought process is instead of an src directory, you have a bin directory, and there are files and the names of those files that translate to the executables. And then your src directories for like library files that you import into those executable files, basically. But the import system is essentially you start with whatever your main file is. It looks at the imports and it then sort of recursively traverses the dependency graph, basically.
Does it cache?
Not at that stage. So it will then parse those files, lower them with a bunch of IRs, etc. The caching doesn't happen until it hits the LLVM layer.
So
Essentially,
you parse all the inputs all the time.
yes.
Like a Java C, if you import X, Y, or Z, he will make sure that the class file exists for X, Y, Z, and then he'll suck in the class file as the pre-compressed, pre-analyzed version.
Right. Yeah, I haven't done that yet because when I recently implemented incremental compilation, I looked at where's the time spent, and I can print that in my
Yeah.
compiler. And it was,
That's
like
not ideal.
90% was LLVM. So it's like, yes, I can do
Okay, fine.
parallel parsing and caching, but it's going to have a insignificant impact.
Right. Yeah.
So I started doing it at the LLVM layer, and it's also a bit easier because LLVM already has mechanisms for example, writing to object files, and if everything up until that point is the same, and you can sort of guarantee that files are processed in the same order and etc., you can just leave the object files on disk. So the caching mechanism is quote unquote fairly straightforward.
Okay.
Now that I've done that, off the top of my head, I think 10% of the remaining time is spent in parsing, and then it's like 10% in lowering different IRs, a couple of percent optimizations, etc.
Well, I was thinking about large projects. Like, what's the biggest project you've got going in Inco?
That would be the standard library itself. I think that's about 10,000 lines or so. So it's not like super large, but it seems to be fairly linear. So you can sort of extrapolate like, okay, it takes this much time for 10,000, so it likely will take that much for, 100,000.
Right. Okay.
What I found there, I think caching at the parsing level and only caching the syntax trees, for example, will be beneficial because you still need to parse that cache.
Yeah,
Might be some benefits,
skipping, is there a way you could skip parsing altogether if you have a pre-parsed, pre-cooked all the way down to the data or whatever?
yeah, so you could do that. Then what you need to do basically for every file that you would normally parse, you need to store some extra file that says, hey, these are the dependencies when I last parsed it.
You need to have some version you can read in and pick up dependencies and symbol tables and shit. Yeah, fine.
I think my long-term plan there is, at least for parsing, I want to do that in parallel and just always parse.
And just always
no caching at that stage.
Yeah, maybe.
And then maybe at the later stages, cache things where it's beneficial, such that you could say bypass certain optimization passes on code that have not been changed.
Yeah.
But I think that is still probably a few years off because in its current state, there are, I think, a few too many things where I would like to improve the way it works in the first place before I slap a cache on top of it.
Yes, I get it.
And these are also layers where I would expect quite a bit of code change to happen. Like, I haven't really implemented optimization passes in the first place, apart from type specialization.
You're handing it off to LLVM. You're talking about optimizations at the Inco specific.
So like function inlining, constant folding. I have not done any of that, and
surely LLVM does that.
It does to some degree. I have them disabled by default. That's based on the idea I want to figure out, okay, where's the time spent? And LLVM doesn't have a clear page somewhere to say, hey, out of these optimization passes, these are their performance. Like, is it linear?
The inlining is the one that typically gives you the most performance gain in the generated code in the end.
But I mean, in terms of like compile times, right? So LLVM has, I don't know, let's say 100 optimization passes.
Yes.
But it doesn't say, hey, if you run this pass, it's going to scale linearly or exponentially as the source code goes up. So you basically have no idea if you want to balance compile time with performance, which passes should I enable?
I'm guessing that LLVM is a classic compiler and they try really hard to be linear in the size of the IR. The constant factors between passes vary, and inlining obviously bloats the code in exchange for faster running in the end. Almost surely they're not dragging in any exponential algorithms unless they come out and say it, because that's a really dangerous thing to do. Almost surely.
No, I would imagine as much, but I think
squared algorithms that grow slowly with a bit vector size. Oh, here it is. The Matt's got the answer.
Right. I'll take a look at it, but
yeah,
basically it came down to like I don't just want to say, oh, I'm gonna enable O3 like a lot of people do, because I want to balance and I want to understand, where's the time going.
A link in the document. The page, also this page up because it's easy to read. But keep going.
It's there. And the other thing there is over time, I want to do more of the optimizations myself.
Yeah.
So that I can do certain language specific optimizations, but also so I can perhaps do them in parallel more aggressively compared to what LLVM can do. But I'm not there yet. So caching basically at that stage, I think is too early, because I would make a cache and then, in the next couple of years, it would change so many times that it's just going to get in the way.
I think that the answer for that slide is it's mostly linear until you start getting pretty darn big at your 10,000 bytes. So it's 100,000 bytes or 10,000 lines, 100,000 bytes are still pretty darn linear. It's a little bit more growth going on there, but it's mostly there. Fine. I think it's a reasonable thing. What was I gonna say? So I've been using Make for a long time, and you can write unreadable code in any language, including Make, but you can write readable Make files. It's super fast, it super parallelizes, it's super simple. The syntax is uglier and shit. Most editors have a Make mode. Most programming editors have a Make mode that do something sensible with Make's bad syntax. Fine. I've done built-in makes as well, built several times. And like I said, Theodore mentioned it before, it's worked out well for me every time I've done it. Something similar to like what you were talking about with Inco, I think. Although I usually have the built-in build yourself as one of the steps. First thing he does, he wakes up and timestamps himself and then decides he needs to build and refork himself.
One of the downsides that you build code inside your source, you build source inside your code, is that let's say, for example, the SBT, the Scala build 2, has to load lots and lots of the standard library from Scala in order to provide you the functions to manipulate the code. Like to manipulate the source code and build it, and has proven problematic. They gotten better over the years, but that still proves problematic. So you want a minimal of the minimalistic core of your language to be provided for the build. So
I've done a build in C code for a C program, and I've done it in Java for a Java program. So I didn't need to, I could assume a functioning standard library in both those cases because it wasn't self-hosting. You're talking about like essentially self-hosting, and your build has to work on the self-hosted build.
Let's say minimal subset of the language, because you have in order to start up fast, the SBT has to load all that libraries, all that standard libraries in order to provide themselves, and that's basically.
Build system was built in Java, it wouldn't. But it wouldn't be writing the build system in Scala, it'd be writing the build system in Java.
Yeah.
All right. Arthur, hey, Arthur, what are you guys using at Azul? You're on, so you logged in, but for a build system.
Well, LLVM is built using CMake, and Hotspot is built using Make.
Yeah. Okay.
All the classic.
Yeah. Well, I don't know if you changed how that was done or not. I obviously did Make for the core hotspot at Azul. Actually, I cleaned up the one from Sun and got the one that I used at Azul boiled way down. Just for hotspot, and all the JDK and the libs and stuff all had their own setup that I never touched, which was probably Make. So Derek, what are you using for a build system?
I use Clojure's built in. There's this, you can brew install Clojure or install Clojure basically on any platform. And then it has this very, very simple system. But I've got this set up where I'm live reloading, sort of live recompiling and then reloading all the Java classes in my Clojure live REPL. So I never have to sort of restart the process.
Okay, but you're not
Works pretty nice.
you're still using a built-in. I'm looking for like, I'm looking for, we were just whining it before we started about working with a great old fanboy. Would be
Yeah,
great.
I don't understand why you guys are doing that to yourselves.
I don't either, and I have asked that question several times. There is a large contingent of Java users who will eventually be our target that know and want Gradle. And I've dealt with that before by having a thin Gradle wrapper over another build system.
Yeah, I was gonna say, yeah.
But this one has been 6 months full-time engineers work to try to get a Gradle builds to go. And like every other week, I spend a few hours on Make and I pick up the next piece of the build setup. I'm spending 1/100th the amount of time
Well,
to get it done in
how
Make.
complex is your build? Like, what do you guys have to do?
It's a couple staged pieces, but it's not that bad. That's the thing that gets me. It's like, you're kidding. So there is a compiler built in Java that compiles ecstasy code, so .x files. There's a large ecstasy standard library, which runs the ecstasy compiler as a Java thing to produce the ecstasy standard library. There are now two backends, the original prototype and the one I'm working on. It reads ecstasy library and wants to run unit tests basically to go do things. So that's kind of the order. There's a one-off special that's done occasionally for updating the Unicode tables.
That seems like exactly the kind of stuff that you can do in a like 10 lines of Make.
Exactly. Yes, you are spot on, sir. Which is why I'm like, why are we doing this? I don't get it. Fine.
Yeah.
So I've been expanding the Make to cover more pieces. Well, there's a release, so you get a release product built out of it, which is intended to get pushed up to Maven, so somebody can do a Maven install. But again, that's not a
Yeah,
whole lot of stuff.
that's not much. Yeah.
Exactly. Yeah. Right. So I don't get it either. Fine.
Yeah, it's the same thing. There's something that seems like kind of inspired by the same kind of, you know, guaranteed employment design methodology
Yeah.
in the Python world.
Oh.
There's pip, and which is awful, and then there's some other thing which I forget the name of.
Wheels. Is wheels not pip, right?
Well, anything boils down to making these wheels, and like the
Okay.
whole
Hey, Aaron,
the
don't you
whole thing
do
is just like
Python?
badly designed.
Are you on yet? No, you're not actually on yet.
Yeah, Wheels was the second build system they made because this guy was like, "Oh my God, Python's build system is terrible. I need something better." And Guido said, "Fine, just don't reinvent the wheel." So the guy came back 2 weeks later and was like, "I made a thing. It's called Wheel. It's our new build system."
That's how it. I was wondering where this name came from. It's such a weird name.
It is, but now I'm amused. Okay, that's good. I hadn't heard that one.
Yes, the name is because they were reinventing the wheel because they were like, "Oh my God, there are so many build systems. We don't need another build system." Except
Yes.
actually,
There were 14
they
standards.
decided they did need another build system.
One standard to unify them all. Now there are 15 standards.
Yeah.
But yeah, the main part of that ecosystem is PyPy, the Python package index, not to be confused with the Python compiler.
Oh,
Yeah.
I see. Okay.
So the issue is you write a requirements file and then it goes, pulls all those requirements and reads their requirements file and pulls all those requirements so that you can recursively have thousands of dependencies despite the fact that you only did one import.
Right. That's
Yeah.
pretty common.
Nobody had thought of the idea of supply chain attacks at this time.
Okay. Wait, has Python
But
suffered?
yeah, it can be really hard to know where all the code came from that is in your project.
Right. I mean, NPM, I know, but did Python have a supply chain attack already? Surely.
I think it must.
Surely,
Yes.
yes.
In fact, I've heard of it with people like do typo squatting for project names and all this stuff.
Oh God. Yeah. Fine.
But yeah, it's always those funny moments when you get something from a giant company like Oracle, except they, in one of their requirements, are pulling something from some random person's GitHub that had a bad password.
Really? Okay, fine.
But yeah, the ecosystem's pretty responsive when a company finds something that's malware and they pull it out of the index. And then anyone who's dependent on that no longer builds, which I guess is better than building with a Bitcoin miner.
Hmm.
Right. Although presumably the Bitcoin miner is already installed.
Well, they have to go fix their own security first anyhow, but yeah.
Anyway, sorry, I took us off track here, but
But surely I joke. All the attacks I've seen were mining Monero, not Bitcoin with your servers. You want something that's CPU intensive and doesn't work well for a GPU. So definitely go after the memory hard coins if you're malware taking over people's servers.
I see, says the blind man. You have experience in this domain. All right. Yeah, I don't think we had any agenda. I was just like,
It's fine. We humanity know how to run software, right? I
yes,
think maybe.
totally,
yes,
totally. It's
maybe.
easy. That's the main thing.
I was just complaining about build systems because I've been fighting them all week, so it's fine.
Yeah, I think it's easy for build systems to go really wrong, and if they're and they can still be. And
Oh,
in fact, I
sound
kind
cut
of think
out.
that the wrongness of
Hey,
it
Derek,
increases
Derek.
the adoption.
Your sound cut out about 20 seconds ago for about 10 seconds.
Okay. My Wi-Fi went out. I'm tethered. Let me try again.
Yeah, all last week or all yesterday when my internet was out, I could get stuff on my phone if I went up on my deck and held my phone up. But I wasn't doing anything beyond short comments. You're still fighting your internet. No, you've frozen because
I'm
you're
back.
back?
Yeah.
Say again.
My Wi-Fi is still out. I went back to being tethered.
Okay. Fine. It's all good. You were saying something and then
Oh
maybe.
yeah. What was I saying? I was just complaining about the fact that I think bad package systems tend to lock themselves in because
Yeah.
you know you have to put so much effort in to get anything working, and then you feel like you don't want to throw it. There's a sunk cost.
There's a sunk cost fallacy there. Yeah, there is.
Yeah. So
Yeah.
I think they're extra persistent that way.
I have lived
why
with
there's
many
so
a
many.
sunk cost fallacy build system in many a company, including some I owned when I told them don't use Gradle and they did. And I said, no. And then it was a full-time
It's
engineer.
best practice.
It was a full-time engineer lost forever. A good guy lost forever to the build system. It's just like, no. Hey,
Yeah.
Matt, do you want to share anything about your build system you work with, or can you?
Ninja. That's pretty much CMake and Ninja.
Meme job?
Ninja.
Like the
Ninja.
Ninja.
It's a fast builder that is used by LLVM.
Yeah. Wasn't Ninja built to compile Chrome as fast as Chromium as fast as possible?
Oh, maybe I have heard of Ninja. Well, how do you like it?
It's fast enough.
It's fast enough. Okay.
Yeah.
I would say
Doesn't
LLVM
Ninja
would be
just
your problem,
make
not the
make
build, but I
files?
don't know.
The other version that I don't know if it's quite sunk cost fallacy. I've seen a lot of companies that get stuck in this short-term, long-term game of we would like to get out of tool X that is costing us a lot of money every year.
Yes.
We know that over 10 years, it would be cheaper to build than keep buying this thing.
Yes.
But
But
we would have to do a bunch of work to get out of it, and it's going to stall our forward progress for 6 months while we do nothing but redo everything so that it doesn't depend on
right.
insert thing here.
Yep.
So what was the thing?
10 years later, you've still got it because every single year it would have cost 10 years.
Yeah.
to
No one
replace it.
can make their way out of the local minima.
The thing was any sufficiently large organization builds its own build tool. So that's like the thing. Yeah.
It could be. Yeah, it could be.
Any sufficiently large organization builds its own tool.
There is some memes there. Yeah. All right. Are we done?
CMake is pretty much hard to displace at this point, but I think for C++, that's mostly the standard now. For
CMake?
better or for worse, yeah.
Okay. Yeah.
Doesn't Ninja just generate CMake anyway?
No, the other way around. CMake generates Ninja
Oh, so you
build
skip the
files.
Ninja
So
part.
CMake is a meta build system. Ninja is the actual build system.
Yeah. I knew that.
But in principle, I agree with that. If you are a large organization, the value you get by building your own tools, if you can increase the productivity of a large numbers of engineers, like
Yeah.
there's a lot of leverage there. It was totally worth it for Google to dedicate 6 engineers for 10 years on Go, because having the Go language made the whole company more productive by more than those 6 engineers at the time.
Yeah.
But Aaron, the engineers that build the build system, the new build system, aren't the genesis as the idea is not new. They will likely take the ideas and make the build system like some build they like. Okay, that's maybe the string. They can pull some of the ideas they like of the more build system, not the only build system, but
We can also
hey,
we can also cut out things that they don't need. A lot of
yeah.
build systems have a lot of genericity built into them. Like the one that you built into the language itself is specifically targeted for compiling the language. Then it becomes seamless to use, but it can't support compiling C and other FFI things that you're going to link in, and documentation of it. It's the wrong tool for that.
Yeah,
But
but
Inco building Inco and closure building closure and whatever building whatever, built
that's
in.
yeah, that's why I'm advocating for it. So if you know the language, you know how to build it. So,
Yeah. And having, like I said, having a built-in one means, yeah, you get to skip all the crap that you don't need to deal with.
Hmm.
It's fine.
I mean, I've seen that in Rustland, where you've got this really nice integrated cargo that does all the things for you and discovers what needs to be rebuilt.
Yeah.
And then you're like, but I also have this folder full of SQL migrations that just has a bunch of .SQL files in it.
Yeah.
And suddenly you're back in a make-land-like thing of this particular artifact I've hand declared is dependent upon all of the things in this folder, and one of them changes, rebuild it.
Right.
so that's why
So
language
it's a
is
pain to specify the dependencies like you have to do in make, but eventually you get to the point where it's like, yeah, that dependency is visible to a human mind.
I think any generic build system has to do something like that, because you can't a priori know how dependencies are found for every possible scenario. That's the whole point of the thing.
Yeah.
I've got doc building tools that come from docs that I got my docs by doing greps on shit. And someday Java doc shows up and does a better job of it. But meanwhile, I just was using grep, and what the fuck, how do I tell that?
I think there's also an element of premature optimization that can happen. Like you can get really granular in your builds and like specify like if this file changes, then we're going to rebuild that. But you can just say like in this SQL folder of SQL file examples, like if anything in this folder changes, just rebuild everything.
Yeah. And walk away from it. Yeah.
Yeah. So like, until that becomes a problem, then
There's
somebody can be like,
XDC
no, let me make this a little more granular.
payoff grid, right? XKCD has a time tool improvement. I don't know, payoff grid. I don't know how to search for that one. Here it is. Yeah, I found it. Is it worth the time? Or I'll throw that into the doc. It's a good one on deciding when to do tools and when not to. Am I going to beat Matt? Probably going to beat Matt there. There it is. Where do we
The
go?
other is it worth the time thing. I hear all these stories of companies that have a big Java code base and they've been doing a whole bunch of resource pooling things to try and make stuff fast. And it eventually becomes such a tangled mess that if you just take away all of the caching and just let the GC do it, things get faster.
Yeah. Way back when I had a bunch of micro benchmarking wars with people who were badly doing micro benchmarks. And one of the big ones was object pooling was generally a lose. Since then, CPUs kept getting faster than memory by a sufficiently large amount that certain kinds of situations, object pooling is a win. That showed up in that billion row summary where object pooling, basically the network buffers that you're using to parse things. My CSV challenge, it was basically object pooling for the win. It was a special minor kind, but it was definitely an object pooling flavored. So anyhow, there's the XKCD comic number 1205.
I do sometimes wonder if an arena structure could give you a lot of what you got by doing hand object pooling.
You could, so in the the CSV file challenge, the main gain after the end, in the beginning, the gain is everybody parses a CSV in parallel, everyone has a big buffer, and they're recycling big buffer. Then as you push down the line, you come to a point where you have to pull a string up and hash and look it up. But if you generate a string, you're generating, that's new memory. The new memory burns through your L1, L2 caches and a continuous stream, even though you're hitting in the hash table 99.9% of the time, you're making a new object to make a new string to hash it. Now you want a pool of one string-like thing that you hash, and if you get a hit and you do 99.9% of the time, you just take that string-like thing and fill it in. It's a mutable string-like, where the next guy, the next, and then 1 in 10,000 misses, and then you pickle up a string and throw it in the hash table for going again. So it's a pool of 1, and you reset it every trip through the loop. Now, is that an arena? It's a pool of 1. I don't know. It's like an arena that you have exactly 1 allocation and you reset it every trip through the loop. It's kind of a trivial version of an arena. It's the ad absurdum minimalist case.
So why is it so hard for compilers to just do that automatically for you?
You have to escape analysis. So particularly
or escape detection.
I'm sorry, or escape. Well, I did escape detection. It worked great. And in fact, in this example,
like I have 3 choices. I can say, I think this is going to escape always, so I'm just going to put it in the global space. Or I think this is going to escape never, so I can put it on the stack. Or it's not super obvious to me, so I'm going to put in a runtime check that detects the escape and does something about it.
That was escape detection out of Zool. Yeah. It did profiling, and then there was a runtime check. And in the case that we're talking about, you would fail when the hash table decided that you missed and you needed to pickle the thing you just failed with. And you would get an escape once in a blue moon, which was perfect for escape analysis. And you would just go make a new version and life would go on. Hey, Mark, there he is. You missed the giant whine about build systems.
I'm sure it will come up again.
Yes.
Yeah, for the 5th time, maybe.
Seems to come up with me about just specifically with Gradle about once a year, twice a year.
What do you hate about Gradle?
It's broken.
How
the number
broken?
one fail, there are several fails in a row. The number one fail is it will fail to compile things that are just out of date periodically. And I would be spending hours and hours debugging something. I would make my change, get the fix, recompile Gradle, and run my test, and it would fail. And I'll be like, oh, that wasn't the fix. Well, I don't know what the fix is now. So I go back to hunting for a few hours, just figure out what was really wrong because the obvious fix didn't fix. And then I would boil it down to, no, surely it had to be that thing, but I just fixed it. And I'd check my code. It was clearly fixed. Then I'd put some stupid print and go compile, and oh, look, it would compile. And the bug would go away. And that was it. I would burn 4 hours because Gradle failed to build. This happened reliably to me about once a month at several different companies with several different engineers running the build system over a span of more than a decade, 15, 20 years worth of Gradle, probably not 20, 15 years of Gradle, where if I was in a build system where I had to use Gradle, it would fail to build things it should have built. So that was fail number 1. So fail number 2 was that it was always complicated enough that it burned at least one full-time engineer all the time, and getting changes in was a nightmare. It would take forever to get changes in, build system improvements, whatever. So fail number 2, whatever reason, either all the engineers that I ever worked with were bad, poor quality, whatever, couldn't did it, or Gradle itself is just impossible to get correct. Take your pick, whatever, goes on there. And then number 3 is it's slow. When I go build the XTC project and I go build from scratch, I can get a from scratch build completed before Gradle finishes looking at the dependencies to decide what he needs to build. So even if he's going to do I only touched one file and building one thing, he's still slower than a from scratch build using make. It's like, oh, come on, guys. Like, what the fuck is that about? So that's my take on Gradle.
Well, once it figures it out, it's so efficient.
There you go.
Caching in build systems and caching in compilers, it's notoriously hard.
Caching in build systems for CLAN has been available and functioning well for decades.
So the part of the language allows for efficient caching schemes,
It-
but
Not really. You have to pound included a billion miles of headers, and everyone reparses them. This is, your
And-
claim. I'm just going to reparse. Well, C
and
does. Yeah, he
you
reparses
just
a billion
hash
miles.
you just hash the first line. Put the
Yeah.
hash in the first line of the header.
Usually hash
So
the whole file, but yes, you hash something
Yeah.
bigger. But fine, yes, you do something there. And
Hmm.
and then the caching says, things haven't changed, timestamps haven't changed. I'll go pull the thing up, fine, done. So there's caching, there's parallel make, which C does as well. It's all good. Java got pretty close. I don't think he does parallel directly easily, but he does all the caching things well.
Hmm.
I mean, other people get this right. I don't understand what Gradle's issue is, so fine. So I'm currently in a war with a Gradle person who's very fond of Gradle. I don't understand the mentality behind it. I don't understand how he's so willfully, I hate to say it, but he's pretty blind to what the cost he's paying is versus the alternative costs. Yes, Mark, and this will just be a fight. I don't want to do it. I don't want to name drop.
I hate all build systems. So
thank you. Yeah, hate them equally. Yes, yes.
so we're at my day job. We're in the process of moving from Maven to Bazel, which I can't pretend to know anything about Bazel. But the only thing I care about is how fast is an incremental build, and so far I'm impressed. But I haven't yet verified that it's smart and actually not skipping things it should build. But
right, yeah, right.
at least its incremental build actually is instantaneous rather than let me think about this for a couple minutes and then get back to you.
Exactly, yeah. And it's from
So-
Google. I have hopes that they got it right. They're reasonable. They could get it right.
Maybe
I
ecstasy
have
should
one
move
good
to Bazel.
story about Bazel and Blaze, the open source version.
Yeah,
It's super optimized for things that can be repeatable, reproducible builds. So it really wants determinism wherever possible.
yeah.
And they ran across this problem that PYC files were including a timestamp of this is the timestamp that was on the file at the time that I built the file, so that it could know whether it needed to reevaluate it.
Right.
And after looking at this for a while, they decided the easiest way to accommodate that inside Blaze and Bazel was they got the Python project to change their PYC file format to have hashes instead of timestamps.
Really?
And in order to fix their build system problem, they just changed how Python does Python PYC files.
Okay, I mean, hashing's a good answer, but that's a pretty heavy hammer. I guess Google's can swing a big hammer and
Well, it
Fine.
fairly reliably tells you whether the file has changed or not.
yes. But you can
In particular, it fairly
reliably.
reliably tells you when the file changed, assuming that you're on Google's virtual file system because you never actually check out the entire multi-gigabyte source repo for everything. So because they use a user space virtual file system for their repo, they would rather have hashes than timestamps.
Sure. But I've had that problem where a timestamp was included. I had build systems where we were including a timestamp, and then that would trigger the infinite rebuild for exactly that problem. And hashes fixed it, and you can get hashes to be statistically so good that you don't care. Oh, Derek, you're muted.
Well, the strange thing is that my computer says my Wi-Fi is not even connected. So according to my computer, I'm not part of this call.
Excellent. Good to know.
We all agree.
We'll just go with
Thanks.
it.
Yes. Oh, I get the little messages from Comcast that say stuff like, "You've got internet," and I
No,
don't.
my Wi-Fi is grayed out as if it's not connected.
Oh, there you go.
Magic connection. That works.
When did
for me.
that start going wrong? My phone will switch to the radio tower and the Wi-Fi back and forth, but he'll update the little icon on the top bar very much slower. So he'll be connecting to my Wi-Fi, and I know that the Wi-Fi is not connected to the internet because it hasn't been all day because the cable is blatantly down. And he'll talk to the radio tower that I can get to when I'm up on my deck and tell me that my Wi-Fi is down, but he'll say I'm on the Wi-Fi, and I'm like, okay, fine.
Which brings me back to my earlier question. Have we as humanity figured out how to run software yet?
No, there is a way to do this. but they're not doing it. I mean, this is the phone not doing it. There is a hard real-time way to track those constraints and say they have to do this before that, and it's not being done. It's lazy best effort. So it's wrong when shit goes bad. Fine. Same for like, I send a text and I'm in the mountains somewhere and it doesn't go. Okay, it doesn't. It Bing says I can't send. So I walk out to where I'm line of sight to the tower and the phone always works here, and I send again. It says, you're not connected. I'm not going to send. I'm not even going to try to send. Well, try. No, I'm not going to try. I'm not going to try. I'm looking at the tower. I know the phone can talk to the tower. I'm not going to try. Fuck you. I have to reboot my phone to make it try or wait its timeout. And once his timeout's done, he'll try. Oh, and it worked, but he won't try. Never mind.
Yeah, I had a similar thing
That's-
actually the other
that's
day. The internet provider here did maintenance, and they very helpfully texted me at like 6 o'clock in the afternoon, like, hey, tonight between 3 and 7, we're doing maintenance, so the internet might be down. I'm like, oh, okay, fine, whatever. I'm asleep anyway. But then my girlfriend wakes me up in the morning. She's like, hey, the internet is down. I'm like, oh, crap, here we go. And she woke me up at like 9, and she had a meeting at 9:30. She's like, ah, shit, here we go. Rebooted the router, and it's still like, you're not connected. I'm like, I rebooted you. They're like, fine, I'll pull the plug out of the fiber box converter thing that converts the fiber cable into like a regular cable. And of course, then it works. I'm like, you have a light that shows there's an Ethernet connection. That means you are connected or not. Why do you not just check every 5 minutes and reconnect automatically? Why do I have to pull the fucking power cord?
I had to do it too. Yeah. I waited until Comcast said, you have internet. Of course I don't. Okay.
Again, caching.
Similarly with, this is,
Caching, yes. Invalidating of caches. One of the hardest problems in computer science.
there's the similar thing here where when we moved in, I made an effort to have like proper Wi-Fi, because in past houses I just had a router somewhere, and it was a decent router. But I never needed more because it's just one floor, 1 bedroom apartments, that sort of thing. But here we have, I guess this depends on what side of the ocean you're on, but we have 3 floors. Ground floor, first floor, attic. Some will count that as 2, I think.
We have effectively 3 floors too.
And so we have an access point on each floor, yada. My laptop doesn't roam properly between access points, in the sense that if I'm I'm in the attic, so it connects to the attic. I go to the ground floor, it won't immediately detect, hey, wait a minute, the ground floor signal is like 80%, the attic is like 10%, let's switch. It's like, no, it doesn't do that.
You get a mesh, it's supposed to do it automatically.
So that's all set up, right? It's all one network.
Yeah.
My phone works perfectly fine with that. The problem there is that on Linux, the Wi-Fi, it's not the driver, but it uses WPA supplicant, this tool that does the actual Wi-Fi scanning and all that stuff. So sort of a user space program on top of the Wi-Fi drivers. And then your sort of network settings, they talk to WPA supplicant. The way they handle roaming is they basically say, if the signal is cut off, then we will scan every minute. That's how they handle roaming. And otherwise, I think they do you can configure it to do like once every 5 minutes or something. And it's apparently because to do that scan, it will interrupt network connectivity, because it can't do regular Wi-Fi network and scanning. I think that's more of a hardware issue. And so basically, it will only cut off when the signal is gone, not when it's shit. So I think I implemented now, there's a setting where you have to go through like 15 wikis, whatever. It's like, oh, just copy paste this thing. And then it says, hey, if the signal is below a threshold, it will scan every minute or 2 minutes, whatever I set it to. But it's still not roaming. That's like, I have an issue. The regular one is I'm on the ground floor. I go to the upper floor, to the bathroom or whatever. And it will take a couple of minutes for the laptop to like switch over. And I'm like, the access point is literally 2 meters away.
just to clarify, you're taking your laptop to the bathroom?
Yeah. If I'm there for a while. It's more convenient than a phone.
That's what phones are for.
No, I can't code on a phone.
So here is the somebody's comment about a new C++ build system. Is ls and the files were called -g main cpp -o main and so on. And he says G++ star. And I guess if they're alphabetical, correct, it'll just put them in order. Or he doesn't care the order. No, he probably doesn't care the order.
It can automatically detect new dependencies if you add new files. So this is the way.
This is the way, just compile everything. And then the new file removal system, RM star. It's no worse than a Godbolt. It's no worse than many of others I've seen. Yeah, okay, fine. Okay. Yeah, I'll have to go uptick that one. That's good.
Yeah. The nice thing is that the file contents can be the explanation for why the argument is there.
Yeah, yes. That's self-documenting. There you go.
Self-documenting. It's better than most build systems right there.
Sure enough.
I don't know if you guys want to talk about Sea of Nodes at all, but
no, fire away.
Yeah, or we can continue to talk about my bad Wi-Fi and my poor connection.
No, I think we can switch to Sea of Nodes.
Okay, so I'm right now trying to figure out how to instantiate objects and stuff. Can I share my screen? I'll show some charts that I've been laboriously drawing.
Yeah.
Here.
Yeah. I've gone back and forth twice, 3 times on my actual layout of objects. So we'll see what you have.
So, well, I've been spending a lot of time studying AA, and now I think I have a pretty clear sense of where things are implemented and where they aren't. But this isn't exactly like AA, but
looks pretty close.
It's pretty close.
Yeah,
it's pretty close. So especially the tuple is really close. And so
for me, tuple is struct. They are identical, just the field names are different.
Exactly. And I did that as well. And in fact, I didn't even like stringify things. I just treat everything as objects. So, which turned out to be a bit of a pain for looking up ints, which I was very surprised at because in Clojure world, it was always no problem, but I figured it out. Anyway, so this is like, so starting here with the tuple.
And proj is probably memory. You have it as control.
Where's
store struct node should surely take a memory input.
That's this projection. Oh yeah, sorry.
Projection, yeah.
That should be mem.
That should be mem, yeah.
Yeah, and so I think this struct node would eventually have some instance.
Well, I would complain that your new is pointing at 2. Oh no, it's not. Oh, never mind. No. Okay, fine.
Yeah,
I withdraw my complaint.
Yeah, so this struct node would eventually have things like instance methods in it.
In AA, it'll have, well, it'll be, okay, yes, that's a good first approximation. It'll have instance, but it also could have other fields in it, class statics.
Class what?
Is that intended to be your class?
Statics, yeah, exactly. It's static stuff. And in fact, I even have it labeled static here. So.
Oh yeah, fine. And then there's your class pointer going into the header of the object, followed by item 1, item 2, and field 01. Yes.
Yeah. So this struct, and then I save it away here, and I have to. Yeah. So. Yeah. So that's sort of this, and this is my environment, and I've already built this setup.
Well, okay, so let me warn you about, I'm playing this game in AA, which I mostly have sorted out, but not 100%, and that's merging the concept of structs and stack frames.
Mm-hmm.
And so I'm using structs for stack frames and structs for regular C style, Java style class struct objects.
Yeah.
And the meaning of when you load a field from a scope is slightly different than when you load a field from a struct.
Yeah.
And so I'm just warning you, there's some differences in how they're treated, and I'm sorting out the differences now. Like I have it sorted in theory, and I'm working the practice bits out. I'm doing mutual let rec this weekend, some hope, and that will sort those out.
So the relationship that I have, basically the field that the inheritance chain is in is different here. So that here it would be struct parent, and so that's actually a recursive search.
Yeah, I put pointers, so I actually have an uphill pointer, so it's always
and for me in the scope I've got structs I don't actually do a new on it. Like, so there's
Oh, I
no
see.
pointer to the thing.
Okay.
And the parent is just the struct node.
Yes.
And then
I've gone back and forth.
in the class hierarchy, the struct node points to the pointer.
Yeah. Yeah.
And so this pointer, and I was thinking about this last night, like the pointer is typed with the value. So this is a bit indirect. And I was actually thinking about putting this connection in there.
Oh, I throw them into the type system. That is, in parallel to the nodes, I have a type system and have a type for the struct.
Yes, exactly. So this, I didn't put it in this one, but this would be type struct. And it would be
I would claim it should be pointer to a type struct.
Oh, sorry. Yeah, sorry, the type struct lives in here. That's right. So that's
no. So the struct node has a type struct.
Yeah.
No pointer has pointer to struct. Pointing to that kind of a struct, like I give them particular types as well, so I have refinements. And then the mem guy is a type mem, a type mem is a collection of type structs indexed by their alias number.
Yes. Yeah. So that's what I meant. So
that's
this is
that
what
syntax there is.
I'm trying to express here, that I'm sort of like oring this type struct into the right place in
the type mem collection. Yeah.
So, but a precise version of this struct actually propagates forward, and it is SSA.
Yeah.
Because as it moves, it's updated, and it can be flow around. So that's so but it's a bit anyway, I was playing with the idea of putting that in there, but I don't, maybe not.
I have also done versions where the new and the struct node were unified. And I've also done versions where I lumped more things together.
I looked at that too, but then I realized I needed to do projections out of it. And in fact,
you're right. And the projections themselves add grief.
So then I looked at this. Oh wait, that's a different one. You know what? I had that, but I deleted it.
Right. Well, there you go. Me too.
Yeah. So this is tuple, and it's like probably immutable. I'm not sure actually, but so I didn't model any changes to it. But so
you wouldn't model them here.
Yeah. So here I actually did like create here actually is a better one. So instantiate a class.
Yeah.
Okay. So this one's a bit more complicated. So here I'm saying, okay, this is a class that's been defined by the user. And so this struct has the fields in it, instance methods or whatever.
Static. Yeah, I would claim anything static, which include instance methods and static fields.
Yeah.
Yeah.
And so I store that away. It's I have this pointer coming out of it. And then that's in the sort of scope that's fairly early on, presumably. And then later on, I'm going to instantiate it. So then that's here. And then this struct node points to this one.
Yeah, I'm doing it a little different AA, but go ahead and finish up and I'll show you where I'm doing things different that are maybe non-obvious.
Yeah, sure. And then, so here again, that was where I was experimenting with this, thinking about that. But so, and that too, maybe not. So the struct node, so here's something that I was thinking about as well, and I think maybe we won't do it, but this struct node is, when I'm first creating it, it doesn't have this member name assigned, and then later I do this and I create like a revised version of this because I was thinking that it would carry the struct node information, but I think
it's not.
I think this is a bit messed up. This was something I was thinking about just before the call.
Okay, it's not necessary. So you make a struct node, and because he's a bulk making a value struct, he initializes all fields, but you can initialize them to whatever, null. And
Yeah.
then as you do stores, you can fold them into the struct just using normal peepholes. If you're going to initialize some of the fields to something immediately and some of the fields you're going to leave at 0.
Yeah.
Yeah.
I think this is a cleaner and also more AA-like, maybe. So sorry to show so many different variations in the thing.
No,
but...
I'm looking. So that the first set is your class, dude. Then you have a struct, you hauled the thing in. So the top left struct, it's or the very top, oh, I'm sorry. Okay, that guy's your class.
Yeah.
And then you have a store of the class to memory, and that was what I was going to talk to you about in a second here. Then there's the new on the right. Go down from the new, you have a struct, which not that new, the new, oh, that's the new class. Yeah, so there's a new that makes a instance.
That's here.
Yeah, and then there's a struct for the instance, which is just to the left and up, that one, that's the struct. That should take in all the fields, but by default can all be zeros, or you have a member name you're giving a value to, it's kind of in the wrong place or whatever, it's graphs.
Yeah.
Your member name value could be hoisted up. And then you have a store to memory, and later you have another store, which is a member field store instead of a bulk whole struct, and that's an update of a single field. And that was me. I went back and forth on having only field stores versus bulk stores, but I like the bulk store because it gave me pre-initialized memory.
Yeah.
And you know, the where, who actually does the malloc when you come to do the layout? It's somewhere between the new and the store struct.
Oh, would you have a malloc? You would have a malloc node as well?
No, I wouldn't have a malloc node. The new should be the malloc.
Yeah, okay, that's what I thought.
But it makes an uninitialized memory until the store hits. But then the store struct is like vacuous except for alignment purposes. It doesn't do any work.
So some of this was just not wanting to show too much unnecessary detail.
Right.
What I was thinking about here, I recognize that if you had this actual structure, it should peep this whole store up into here and combine it all.
Yeah.
But you know, I was thinking about like how it would look if, you know, there's lots of intervening stuff and then I need to update a field.
Well, it's the edge thing. Okay, let me tell you about C2, which does things a little differently, because this is me experimenting in AA. The C2 version is you're all pre-split by field names immediately. So the new is a black box, just like you got a new. It produces a pointer to memory that's been pre-initialized because the runtime, when I do an allocation, is going to zero it for me. When the compiler gets a hold of it and begins to do things to it, he's going to have aliases done on the field level already. And so all stores, they don't have to deal with store struct. The store struct has been folded into the new, basically.
Okay, so basically so then the memory
goes into the new. So weirdly, the memory of all fields goes into the new, and the new produces an initial struct with pre-zeroed, and he needs the initial memory to not alias against other instances of that kind of an object that are being made. So a sharper version would be the new would take all the fields that are about to get set here. Yeah. But I don't bother to split them out in C2. He just takes a bulk memory and he doesn't allow news to bypass. Now in the land of Azul's C2, I did the fix to let news of an object until it escapes were known to be independent from all other instances of that object. If I make a new person here, and I'm being passed in a bunch of other persons, got a hash table full of persons, the one I just made is known to be independent from all others until that pointer escaped. And I did a very lame local escape analysis.
Do I understand in this IR, the type information like struct nodes, I think I saw some field descriptors, are represented as nodes in the IR?
No, the type information is kept as a separate thing. But you have to
Oh.
separate out what you mean by types versus sort of semantics here. So if you look up the top left light blue struct node has type struct underneath it. I would have a type struct as a separate thing, has nothing to do with any node in any graph. And it would have a list of field names and their types recursively, like you would expect out of a type struct.
Yeah.
But it's not a node in a graph.
Ah,
Yeah.
okay. I thought maybe there was some like extra level of dynamicity where we can manipulate types, so they need to be represented as nodes and as values.
No, but there's a lot of type manipulation going on, but it's all of what you'd expect of types. Like the new node that feeds from that struct is a pointer to that kind of a struct. Given a new node, I can ask, what is your type, Mr. New Node? He'll say pointer struct. Well, then I can say type pointer dot load, and I got the struct type now with all its fields. And then that struct type, I can say, give me field called member name, and I get the type of the member name field, and so on.
Mm-hmm.
Just what you expect out of doing things with types, but they're not nodes.
So this the new node then has to have a projection coming out of it, I guess, because you've got memory and the
No. So
No?
so
Oh,
that
the
memory should go to the project root node memory, not from the prior new. You have two news in a row. One new, they don't need memory. News, okay. So here's where you have to decide how you want to do
it
this.
allocates.
No, new does not need memory. New picks a new chunk of memory that has always existed since all of time.
Okay.
And therefore he doesn't need a memory. He only needs a memory to root ever. So you don't have to have it. Just get rid of it.
So it just I see. So right. So it's like a new sort of split that has no relation to anything that's ever gone before. So there's no need to worry about anything that's gone before.
That's correct. You can also think of it as like I'm a constant, but kind of like a random number generator constant. I have no inputs, but I produce a unique output every time I run through. But he doesn't need a memory input. And that gives you some flexibility about how things are organized. But then promptly when you actually go to emit code, the memory you got from the new will not be initialized typically. Now you could go back and forth on that, right? And decide how you wanted to have a new emit code as. So the new is a bump pointer allocation on your thread local allocation buffer. Okay, it is. And now what do I do with the memory? Do I assume it's been pre-zeroed? Well, then I can have the initial struct baked into the new, and the edges from the struct and the edges of the new get coalesced into a single blob. And I produce a new struct out and a new pointer to that struct. Yeah, this is one of the forms that I had in the past, where you drawing right there, where the new produces a memory and a projection. I don't now, but I've had that version. And I broke it out into these three.
In C2, it must need to have that though, right? Like,
yeah, C2 has this version. Yes.
yeah.
Because the C2 version says I'm aliased against all other persons when I make a new person. Therefore, I have to order against all other persons. So I take in all other persons as an input memory, and I produce all other persons as an output memory, except I produce all the fields, not the person as one thing. I produce all the fields of a person, take in all the fields of a person. And then there's shortened variations. Semantically, I take them all in. There's short versions where I don't have to have a bajillion field edges. I don't have 1,000 edges. But the shortcut just says this one projection approximates how many fields a person has.
So if say this is a person that we're instantiating,
yeah,
and this is the person.
This is the C2 flavored version, so it's less precise, if you will. Fine.
Yeah. So this is the person static. This is the person instance.
Yeah.
Then if I do another one.
Yeah. He has to thread off of that guy's memory.
He does have to. Okay, so it's only the first one of the type that goes straight to root. That's what
it goes straight to the call entry point, because I'm a function call level compilation. So in from the main function comes pointers to other persons as an initial thing created at root or function start. I get pointers to other persons and some memory of persons, and I need to single thread whatever. C2 immediately gives it up and says, hey, if I have a new person, hit aliases all other person objects. So I'm forcing ordering on the memory piece, and that forces the ordering with other person updates. So I'm not confused. I get correct answers. the Azul version says, the new one I made, until I store that person pointer into an unknown place, and I'm pretty weak on what means unknown, he's separate memory. As soon as I store it to somebody else, I'm separate. Sorry, while he's not stored, though, he's private memory. So all the updates on the new person I made, which is actually really common because the constructor does a bunch of shitty shit inside, and that all works. But then promptly leaving the constructor, you store that person pointer somewhere I gave up on, and then he says, yeah, you and all the persons, and that makes that point have a merge mem where I merge the private person memory with all other person memories. So you end up with a merge memory, which C2 doesn't do, but I did it at Azul for a while.
How does C2 get away with not? C2 just keeps these, but like, how can C2 not have a merged memory between, you know, this one? Well, I guess this one's inheriting.
So C2 isn't distinguishing the two instances of new persons. So they just single thread, just how you drew them right now. They thread one to the other.
Yeah.
And updates to the first one have to happen before the new allocation of the second one, and anti-dependencies will force that.
Yeah, okay.
So I'm not claiming it's the best answer. I'm claiming it was the thing that got me through that piece, and then it turned out later in life to not matter a huge amount.
Yeah, I'm just you know, I'm trying to figure out what I can do that's as simple as possible that'll work well. And I'm also, you know, dealing with relatively smaller programs. I don't know if that makes a difference. And I don't have as much dynamism
right
as
so
AAA. So
the simple version that C2 is doing here works well on modern x86 in that, like, fucking stores hit the store buffer forever today, and if you didn't delay them or you did, it just hardly matters. You're not having multiple updates to multiple person objects that want to bypass and optimize independently. Usually you factory up a person object, you screw with it for a little while, and now that's the only one you've got, and so you don't have to worry about aliasing to other ones. The one time that really hit is making new iterators for for loops. When the for loop syntax sugar came out, you would say for person colon person's collection, then you got an iterator. Well, if you had a second iterator, they alias to the first iterator. And if it was one after another in separate loops, you're okay. But if you nested, so if you had a for int in a collection of ints and a two-dimensional array for the second int, with the second int array, the nested int array, the inner and outer iterator would alias, and you start to lose precision that let you clean up the iterators. And he'd end up having stupid loads and stores of iterators inside the outer loop. The inner loop probably cleaned up. I don't remember, but I remember having issues there. But the actual, I don't do anything fancy with the person memories, and you just force everyone to alias. Wasn't a huge win. What I did at Azul, it clearly helped. It clearly helped by a small amount. So,
yeah, I was actually thinking of doing my first version of memory just as one sort of generic memory, and everything is the same sort of state.
Oh,
and
you totally should, because that will sort out all kinds of other things. You have to get it through calls. You have to get it in and around your allocations on ifs. They want to float up and down shit. You got a bunch of things to sort out.
Yeah, yeah.
And
I've done it already. I mean, I kind of know what I'm in for.
Okay.
You know,
well, right. Like in simple, we're going to do it this stupid way first, for that very reason I said there's a lot of things you got to sort out. Then we'll come through and say, okay, how do you want to do it? And in C2, I broke it out all by fields, and in AA, I'm doing structs and then fields by name. So you get it by fields with a level of indirection, but it should be as precise as fields, but without a bajillion edges everywhere.
Yeah. And this was my problem in my first cut, that I made everything fully precise from the beginning, and there was no concept of splitting or merging, and and that actually worked okay, but it was hard to look at the graph. But I eventually just built a version of my graph viewer that just got rid of all those edges.
Right.
Problem solved.
Yes.
So, except when I needed to debug them.
And then the C2 version, you end up with everyone having one common root memory that says, I'm all the fields. And then everyone points to it, but I can tell from context that this guy's referring to the person.name field, and that guy's referring to the animal.legs field or whatever it's going to be, right? They can tell them apart.
Yeah.
And then at places where you can't, I stop and I just get imprecise on purpose. I just like, okay, your bulk set, and I'm giving it up.
Yeah. And then the other thing I was looking at is primitive arrays, and I think that's simpler. So this is what I have, two variants, one where it's instantiated.
Yeah.
And one where it's blank.
In the struct version, you kind of conceptually want to have a struct creator that makes a bulk struct so you don't have uninitialized memory. And then you want to optimize it conceptually against all the initial writes. So you have a struct that takes in a bunch of zeros. And then as you say, I'm storing at the member name, the person's value, I replace the 0 with the value as you fold up things. When you go in an array, you never do that. You say, I make an array, I want it bulk zeroed. So I need a length on the array node. I don't need any item counts.
Yeah.
I need a length, the type's baked in, and boom, I have an array. And then I have to have a store to do a memory thing, or I have to have a memory guy have projections, which is the older version, but you just like you got there. Yes. Just like that.
Yeah.
So
and
you
then
have
I
one
thought
more
that I
node
don't even
for
need
structs
this
to allow you
struct
to
node input here. I can just have it as a bunch of arguments or like a bunch of def straight into the input straight into this new array node.
Okay, if you, I'm sorry, what is item 0, item 1?
Just like members of the array. So like this would be a array length 2.
And here they are.
Sort of.
Yeah, don't bother. You have a store array. Go ahead and put the store X nodes. And then if you have a bulk of them, you want a bulk struct node with but a bulk array guy. I would keep the array node guy clean, just takes a length. He walks away, he has an internal type, he has a length, he produces, yeah. I would put them on a store index, and then later if I had a bunch of store indexes, because I'm pre-computing a classic pre-initialized constant array, then I might make a bulk array store array node that took a bunch of indices, like all of them, like demand. I'd only do this if you're going to completely fill the array out. Okay, so I have a store array that takes nothing. I have a store array variant that says, and here's all the values in order for the size of the array.
Right. So then I see. So then that would just go here.
Yeah, that would just go there. Yeah.
Right.
And in this version, you're not.
Again, this version would obviously this value would would replace whatever value is at whatever offset it is. Yeah. But I'm just assuming that this is like some time has elapsed.
Yeah, the line. Yeah, I understand.
So
something magical happened in between that screwed with you, and now you're.
Yeah, like I couldn't just combine, but I just want to sort of get the sense of what the store would look like.
Right.
Or the pre-peopled version.
The pre-loaded version, whereas the one on the left is just a blank array.
Yeah.
You don't need the struct. The equivalent of the store array with extra inputs is the struct node on the right-hand side. You don't need that on an array. The left-hand side array doesn't need one. The right-hand side array needs a struct-like thing. You're calling it, you've mixed store array with struct behavior. So go to your other regular class guy, your first cut of your class guys, pick one of your structs and one of your stores, merge the struct and the store together. This gives you another combination. Like you have 3 conceptual pieces, you can merge any 2 together into nodes. So you could blend the struct and the store together. Then the struct says, oh, I have a whole lot of fields I'm storing. Here are those initial cuts, and I'm just completely populated with those initial things. Now I don't need a struct node. I need a store of a struct which has every field mentioned. I need a store which does field by field, because that's the common update one field. I don't need a struct node. So you get rid of one extra node flavor, and you make store struct be have extra edges, one for every field he has to initialize. And initial 0 is common, so you can take shortcuts like nulls or whatever, how you shortcut that. But semantically, he stores all initial values.
Right.
And then you don't need to store node.
This is like again, this is like a later.
Yeah. Right. I broke out store node from store struct so that I could imagine a store node producing values which only sat in registers. but I think that's sort of a premature optimization. Like if I'm doing Java, not Valhalla, whatever maybe it is Valhalla. It's the one where you have objects and an array of raw objects with raw points or whatever with no headers or anything. And I want to load that by a value, then I load multiple fields in registers. It's just only ever exists conceptually in registers.
Right.
That would be a struct node. But maybe I don't need to have one. Hey, see Arthur.
Yeah, so the one node in all this mess that
Arthur, do you have to go? Did you want to say something before you left? Or is he gone already? So I thought I heard Arthur trying to add something before he had to go and he dropped. Okay, never mind.
Sorry.
Yeah, don't worry about
it. The one node type that I actually have in all this mess is the struct node. So it is not a huge win for me to get rid of it because I already have, I'm using it here. But
well, so in the struct node for the environments, I kept the 3-part pieces. Like I said, maybe I'll fold those up. And I used pointers to go up the class hierarchy so that my frames, each of those structs on your environment, basically stack frame, could be heap allocated if I wanted to have full closures. And if I'm never going to have a full closure, then I don't need the pointer. So right now, AA has the pointer for the environments, like a struct for this stack frame has a pointer to the prior stack frame, which if you put them on a C stack, you wouldn't need the pointer because you got past the stack pointer as part of the C stack hardware calling convention. But if you have to go do a full closure, suddenly you have to move the stack frame from the stack to the heap. Now you need a real pointer. So I just modeled them as a pointer to, instead of struct to struct to struct, it was struct to pointer to struct to pointer to struct to pointer. Right. All food for thought. None of this is stuff that I've done in C2, so I have proof that it works. It's all stuff I'm playing with in AA.
Yeah. Yeah, it seems like all of these seem viable. So one thing I'm trying to figure out is how often am I going to be able to kind of get rid of all of the stores entirely and just use, like, basically access the, sort of split the members of the struct out when I need the, like, so instantiate a person in a function and I use that person for various stuff, and then I don't even I kind of kill that person, or kill that person object in the function, then can I actually peep away all of the stores and just start using the field?
I was designing AA to let me do that because I had seen the trouble it was in C2 to get rid of small, short-lived new allocations. So at Azul, I restructured things so that I could peep away new nodes of, I had this private versus public thought. And if I had an unescaped private new who had a bunch of stores to initialize and then loads to use, as the loads bypassed the private fields, because it was all private memory they could bypass, they would get the initial values. Suddenly the loads go away. Then I have a stores with no consumer of an unescaped guy. So it was a special peep that said, hey, the pointer's not escaped. I have a store to the address of the pointer that's not escaped. I don't need this store. Then those stores roll up and eventually the new folds away as well. So it can be peeped. And it was specifically targeting short-lived new allocations, and the iterator is the poster child, but people do plenty of those in other contexts.
But it should also work for things like, the static class is defined at the top level and you store and it's all constant, and then you use a member of it and you just sort of grab the constant member.
That is one of the goals of that, and it should in AA, and I haven't tested. I didn't do that explicitly in C2, but it should let you do it. C2, the classic struct fields were given a private alias. The static fields in the class are just given a private alias.
Yeah. In my first cut of the compiler, I made it so that my struct nodes that I created didn't even have the ability to store themselves. and the compilation would fail if it couldn't figure everything out. And usually it could, even if the accesses were deep.
What do you mean a struct couldn't store itself?
What's that?
I'm sorry, you said a struct couldn't store itself? I missed.
I mean, like there was no way to like create a pointer to an object. There were no structs in memory. I had struct nodes, but no new nodes.
So that would only work if you in
concept.
registered, and including spilling, the entire contents of all structs.
Yeah, so the struct actually had to go away completely, but before the peoples were done, and that worked.
It did.
So
we had no aliasing.
Yeah, well, so then I had restrictions, like I couldn't have multiple. Well, it would figure it out right across call sites and stuff, but there were definitely restrictions where like ambiguous stuff wouldn't work and it would fail to compile. But most of my programs were so small that I never actually hit those cases.
Yeah, right.
So, but then again, it was also sort of more of a, it ended up being just a proof of concept because we decided to, retarget to the next generation hardware. And then I was like, well, while I'm doing that, I'm gonna not fix all my issues. I'm gonna start over.
Yeah.
And fix them all sort of that way. So then I didn't have the consequences of that stuff. But where it could keep it straight, it worked fine.
Yeah, sure. Well, it's very cool that you're doing this because I don't get a chance to talk about this with somebody who's trying to make it work. And so go work through the design decision math is interesting.
Yeah, but I think I'm, it seems like there's a bit of indecision with like a few different variants on the screen here and stuff, but I think I'm going to be starting coding tonight on this. Like, it's
excellent.
Pretty much big.
Yeah, you're making me think I want to rethink having struct nodes and I should toss them. I've gone back and forth recently. And I'll have a store struct, which takes all fields, a no struct node, and I'll just not worry about it.
But
I mean,
it's funny because I was thinking that maybe the store struct could be a subclass of the struct node.
Oh, yeah, right now my implementation I have a store abstract, which does common things for both flavors, and then a store field and a store struct.
Yeah, I spent lots of time looking at it, so here it is.
Oh, okay, fine. And the prim guys are stale now, so you could take them with conceptual grain of salt only.
Yeah. So started with looking at that because I couldn't figure out. I finally figured out that new node is the real pointer.
Yes.
Took me a while to sort of work that out, but yeah, there was some stuff that I didn't quite understand, like why the struct. It took me a while to understand why the struct node had this like.
New node top. Yeah. Okay. So this is a stand. That's the new node top is the type for class, if you will. Somewhere at the root of the primitives in the universe, there's a class made with a new node. And class has no fields, and it's just the root of the class hierarchy chain.
Yeah, and then I figured out later where the pointer of this was actually created. So it's actually created in the env.
Yeah.
So yeah, like so I feel like I'm kind of like digging through the code and reverse engineering, and I'm getting better at it as I go. But it's interesting, so I kind of like doing it.
You can so you can ask always, but you can also reverse engineer and learn, and then come back and ask and say, "Is this what's going on?"
Yeah, that's what I prefer to do. I try and like figure it all out on my own, and then like,
yeah,
get it. So
there's
mistake there. So you've got the field nodes, which I believe are just so that you can put the access.
I dropped field nodes.
Oh, really?
I don't have nodes for fields. There's field node exists as a load. That's a field load.
You have field nodes.
Yeah, that's a load. That's a field load. That is.
Oh,
you got it in the wrong side. It takes a struct as an input and slices out a field.
Oh, okay. Okay. All right. Yeah, okay. Anyhow, yeah.
I had at one time some kind of a thing prefixing a struct for that, but that went away a while ago. So
okay. Anyway,
there's a load of a field And then there was a load of a struct, and I thought I had ditched the field loads in exchange for just making load node do fields. And I went back and forth on this very topic, and the field node is now stale. Source meaning
okay.
Java, blah, 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 node. Boom, I have okay, so master has field nodes. The cleanup branch, which I'm currently hacking in, does not. I have removed field nodes.
Okay.
I
Okay.
have pushed them into loads with a field name.
Okay. I'm
But
not
they-
going to try and update the graph here because I don't quite understand. But
Well, the field nodes were take a slice of a struct. So you have a struct that has no memory effect. It's just a collection of items.
Yeah. Yeah.
A field is a projection using a name as opposed to an index to pick out a particular guy.
Right. The name here would be
The field
0,
name.
like that.
Yeah, if you're a tuple, the field name is 0, and so the field slice, it would be named field 0. But if you're a person struct, then one of your fields will be name, and one is age, and you have a field that has, I've sliced the age field out.
Yeah.
But they're classic projections.
Okay.
And then,
Okay.
as you pointed out, I don't actually need to project by, well, I was doing projections by name instead of by index, because there's heading for Hindley-Milner, which has order invariant structs,
Yeah.
so you can't
Well,
rely
you
on
have
the
this.
index order.
You have this whole bits tree thing, which
Oh,
I was struggling to understand, but I think I kind of get it. That
you want to
well, I
tell me
don't
what you
understand
think
how
it
it's
is, and I'll
implemented.
tell you if you're right, or I can
Well,
tell you what it is.
so I think that the bits thing allows you to have a bit set representing your memory so that you can keep track of your memory splits and merges. And then it also has this tree structure so that you can somehow you can basically say that you can like recognize the subclassing type relationships. Although I'm
Yeah.
not sure because I couldn't tell if you actually had subclasses in this in AA. It didn't seem like it.
I have them, I do. They show up in a funny way. Everything in AA is all by sort of first level type inferencing. You basically can infer subclassing.
Uh-huh. Oh, okay.
But
Yeah, so like I've spent zero time trying to look at or understand anything about the Hindley-Miller stuff. So sometimes there's mysterious stuff and I'm just like, that's probably part of HM and I just ignore it.
yeah, that's fair enough. No, the bit stuff is not part of that. So the bit stuff, I use it for functions, I use it for aliasing for memory, and I use it for RPCs, which is closures, which you can ignore. It's so that I can take an alias class and split it.
Uh-huh.
And that would happen when you inline. So
Okay.
so aliasing in AA is done not by user saying I have a person object or not. It's every new allocation site is immediately its own alias.
Yeah.
So you have aliasing per allocation site. If you mix persons from this one allocation site with persons from that allocation site, you do, that's fine. Then I'll pick up multiple bits, one for each allocation site. That's okay, it's all fine. Okay,
Mhm.
if you take an allocation site that you already flowed and you have complete knowledge of it throughout your graph, and you want to incrementally inline, which splits the allocation site, then the new allocation sites are child aliases of the parent alias. They're private when you first put them in the graph, but the rest of the graph contains the parent alias bit. So then you get correct, incrementally correct, improving over time alias information in the face of inlining.
So I do not understand why inlining creates any kind of parent-child relationship between the new nodes that are
Okay.
in the original and the ones that are inlined, which seem like kind of equal status copies to me.
Right. Okay. So I gave somebody some alias number 2. He lives in a function that is part of the greater graph, but he's in a known subfunction. He's called in with some things. He produces twos, alias twos, which flow out. They flow around through the graph. He comes in and out. Twos are everywhere. He's seeing a 2 because he got handed the hash table full of his own things and he's adding a new guy in. So he's got whatever. So alias 2 exists everywhere. I inline this guy at a particular site. At that site, I have a new allocation. I want to give it a different alias number because all my aliasing is done by allocation site. So now I give this new guy, say alias number 3. I go to the old guy, he's different from the 3 guy, so I'll just consider him a new site, give him number 4. The rest of the graph is full of alias number 2s. Well, alias 2 covers 3 and 4. So if I ever come across a place where I have a known pointer of alias 2 and a subpointer or a store or load of alias 3, they know the alias, and I can't do certain things with that. Whatever peoples are allowed there because they alias. Or if I come through with an alias 5 and I see an alias 3, I know they're independent always 100% because that's the equivalence class and I can bypass. But I have 2s where I have approximate knowledge, where I've accidentally mixed 3s and 4s together. So a 2-bit in the tree can always be now expanded into a pair of bits, 3 and 4, equivalently.
It can be expanded to 3 or 4, but
and
then
4, because I can't tell. Under the old pre-inline state, I called this function, I got a 2 out. I called it again, I got another 2 out. I ran those two 2s together, but they're already both 2, so it's a 2. After I inline, I got a 3 out, and then another guy got a 4 out, but they were all run together, so it's a 3 and a 4. Now, I already had them run together as a 2, but I blew the 2 out as a 3 and a 4. Now it's just identically to how I had a 3 and a 4. Then I can come through and start saying, oh, but here I can blow off the 4. I know I don't have a 4. I can sharpen myself to just the 3 or just the 4. But everywhere where I don't know yet, I have to say it's both a 3 and a 4 because it used to be a 2, which was in fact the earlier version of a 3 and a 4.
right. So basically it changes what the 2 means, and it now means 3 and 4.
Yes. So when I split an alias number, you get 2 sub-aliases that parent to the prior alias, and it's it's as if it had been split all along, I just didn't know it. The 2
Right.
was always a 3 and a 4 collection, I just didn't know it yet.
Yeah. Okay.
And then I do things to
That's where
canonicalize the form and
that's where the tree structure comes in to
That's
the
where the tree
bit.
comes in.
That's the only place it comes in.
that's how it comes in, that's correct. And then it
Okay.
has to be hashable, which means the 2 has to hash to the same as the 3 and the 4. So I can look
Oh.
them up in global value numbering tables and the like. I can do hash table things with them. So there's
then
some
I guess you just,
canonicalization.
if something has a parent in the tree, then you just return the parent's hash.
Yeah, you can go look up how the hashes are done. Yeah, people will. If you have a parent in the tree, then the canonical form says the parent already covered you, so you go away. So I remove the subchild bit. The
Yeah.
parent bit said it already. When I'm looking
Okay.
at a pile of bits, I grab a bit. I say, are you a parent bit? Oh, you are a parent bit. You have some children. You already include all those children, so I'll get rid of the children's.
Yeah.
Because you're already there. Now that I have you in canonical form, if there is a parent, he has no children's because the parent already covered. Now I'll hash you.
Okay.
And actually, I have to go the other way too. If all your children are covered, then I must replace you with a parent bit and get rid of all the children. So if I split you into 2, then if both 3 and a 4 show up, I get rid of them and use the 2 version. So I always hash with the other 2s that already existed. But sometimes I split you into a 3 and everybody else who may be other things I don't know yet. You're not a closed form. You're not an actual split. You're just, I peeled one more version off. And that's a little different. Then I don't fold you up.
Okay.
Yeah, the bit thing got a little more complicated when I tried to do inlining and then realized I had to either restart my analysis from scratch to get the precision out.
Yeah.
And I didn't want to restart from scratch, so I put the split in. And now you could argue that I made my life more complicated. I should just restart from scratch.
Yeah, and in the previous one I ended up having a couple of points where I did do the restart from scratch, and
yeah,
the whole thing was slow anyway, so I couldn't tell the difference.
There you go. Yeah, it wasn't that I was trying to be fast or slow there. I was trying to push the boundaries of what I could do in an incremental approach.
Hmm.
And
I
one of them
see.
was, oh, inline makes me restart. Shit, can I fix that? The answer is I could, and it got more complicated. Now, is it worth it? I don't know yet. Maybe it's worth it, maybe it's not.
Yeah. But you really, your restart is somewhat limited, right? Because you're only restarting everything that has that type. Right. So you could potentially walk through the graph looking for, or maybe even keep track of what
I
has.
walked the entire graph looking, I've already restarted. I might as well just restart.
Yeah.
It's like linears. It's all linear. So if I have to go look linearly, I might as well restart.
Yeah. Yeah.
The kind of the rule is, yeah, if you have to, if anything you do requires you to look everywhere, restart.
Yeah.
You're done.
I'm trying to think what else I have that's interesting, or maybe that's enough for today.
I don't even know what time it is because I got the
Let
clock
someone
on.
else
Oh, it's
go.
actually time. We could wrap it up. I don't care.
Yeah.
Either
Okay,
way,
well,
we could go a little more, or we could wrap it up.
well, there's one thing that's interesting. I just have to see if I can find it here. So yeah, I don't think I have a good drawing of it. Let's
You're
see
trying to do
here.
something with calls, I see.
Yeah, I was trying to figure out the call, like how the call. This is I pasted this whole thing into
Yeah.
into the chat the other day.
Yeah, pick one and zoom in. We can talk about it. You have
Oh,
the
right.
prim
Yeah,
node at the
okay.
top is incorrect. That is not the right answer.
But this
Yeah,
whole thing,
the
this one's
first
not.
prim at the top, yeah, it'll confuse people. I would nuke it.
Oh, okay.
Yeah, prim node is like an add or subtract or something. It's a regular old node and it lives in the middle of a function body. It never feeds. A fun node is a control node. He takes control inputs from call sites.
Yeah. 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 It's basically a lot like a region, right?
It's very much like a region. Yep.
Yeah.
So if you go down to the call node at the bottom there, I
Yeah.
have what I call linked and unlinked. When I start the world, I don't know who calls what. So you are unlinked and the call knows he's unlinked and he approximates that by saying, I might call every function on the fucking planet. So the call epi in turn says, I get called by every function on the planet. I don't know.
Yeah.
Then during the optimistic analysis pass, I figure out who actually gets called or has a chance. It's approximate, but who actually could be called. And every time you could be called, I link it. And the call has a direct edge to the fun node at the top. You're pointing at the function pointer, but the function pointer is a collection of all possible functions. It's typed as a collection of all possible. Well, it could be off a feet. No, the feet's fine. I don't know where that function came from.
But I thought the function pointer is a specific instance of one function.
Yeah. Yes. So here your phi merges two different function pointers.
Yeah.
And in general, I have a collection of function pointers that feed into a call. I do a flow analysis. They have function bits, just like the alias numbers. I discover that I have two alias bits. So call calls these two guys. I make the call directly point to the fun node, or the fun node point to the call. So that way I have a local information at the call function border that there is type flow information happening.
So you've got something that's pointing like this?
The other way, fun points to the call. You have it backwards. Like flip the edge pointer. This happens during any time I know exactly who I'm calling. Like I've lifted the function pointer from the bottom function pointer, like the I know nothing function pointer, to some specific collection of function pointers. Then I go ahead and link them up.
Right. Okay. So just getting rid of this whole thing.
No, you could leave the phi in there. That's fine. You can have two. A function can have two function pointers and call one of two choices. That's fine.
Okay.
And he maybe calls only one. Commonly, he only calls one. But he can call two or three.
In this specific case, you wouldn't have this edge if we had this as well, would we?
Yeah, we would. Yes.
I drew this backwards again.
Call links up all and not the call epi, the call.
Oh, whoops. Yeah.
And then the call epi points to the returns. as part of the linking step. Both edges are put in at the same time.
Yeah, so I've got those.
Okay, now, and I don't put those in until I have the ones from the call to the function. Now I have standard flow analysis, flow typing things happen here. Multiple
Yeah.
returns go to a call
Okay.
epi. He does a meet over his returns.
Yeah.
Call epi produces some values out that represent the meet of the memory states and the meet of the returns from the two functions.
Yeah. Okay. So see, I saw that this was happening, but I thought it was coming in through here, right?
No.
So
So it's
that
generic.
like little triple jump.
If the feed didn't exist, because you had a simple jump, because you have a call that calls exactly one target, and he knows he calls one target, then exactly the call lines up to the function, the return lines up to the call epi, and the information just flows straight through them as it's all identity functions, and you get perfect knowledge containment with a single call calls a single function.
Yeah.
And that's one step away from inlining, where you simply get rid of the fun to the call edge, and the call epi, the return edge just clears out, and that's an inlining call.
Yeah. It's interesting because it's like just like a better version of what I had sort of tried to do with my previous one, where I had this wired in call sites.
Yeah.
And the only real difference is that in my previous one, I had like two representations, and the first one was with the arguments on the function node, but then I would change it, and I would move the I would have the well, not that one, but the parameter would point to the argument
Right.
directly, and then I'd have this kind of like in kind of invisible, like a different kind of graph connection, which wasn't like part of the regular graph,
Right.
pointing to this thing so I could keep track of it, so I could bring it back. This turned out to be extremely complicated.
Right.
And the source of a lot of problems for me. So I decided I needed to change the way I was doing things.
So the draw layout you have here is function ahead of the call. You could reorganize the graph so the lonely function, the call only calls this function only called by the call. You can move the function in the middle between the call and just what you're trying to do there. Yeah.
Except all the graph lines go.
Well, many of them should square off after that.
Yeah, I just have to get rid of all the like little curve points.
Yeah, okay. So don't do it now, but there's a thing there that says a single call calling a single function.
Yeah.
I all but inline it directly, and then I do finish it in inline, but the alias.
Yeah. In fact, I did that here. So here, I think. Yeah. So here I've got this where I've got the function before, and then I like kind of rewire it, and it ends up being like.
Well, yeah. Okay. The chart that rolled by has a call at the bottom. Here, I would put the call at the top.
Yeah. Yeah. Okay. Yeah, you're right. That would shorten up all of these long curvy lines.
Right. And the fun pointer is an actual data value, not control. And it reads from the return node just so I have a hook to keep it alive, but it's a standalone constant like 17 or pi is.
Yeah. 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 Well, it would be. Is there ever a case where it's actually something that's written to memory?
Yeah, I put function pointers to memory.
I guess it would be the address of the where it's laid out.
Well, it's the code address.
Yeah.
It's pointing at the return to keep the return alive.
Yeah.
But its value would be the address of the start of the function.
Yeah. Let me go back here. Yeah, that's right. So this function is pointing to that. Yeah, I got that. And this is also a nice thing, because what I had before was that I had the pointer pointing there, and then I had to have this secondary connection to keep the return alive. So I had the function point back to its own return, which kept it circular. But the problem is that then I didn't have a natural way of getting rid of it.
Yes. So if a function pointer has no uses, that function is not getting called, and the function actually deletes.
Yeah. So that's nice. Yeah, that's a nice, way nicer. So I'm going to adopt that change. So just showing how I had it versus how it should have been.
No, I went through several cycles to get to here. This didn't come from whole cloth from my head or anything.
Yeah.
It came around with some amount of trial and error.
But it also goes to show that you can create like a sea of nodes graph that's got lots of like relatively poor decisions in it and it still works pretty well.
Oh, good. I wouldn't say they're poor. You just have to try it and find out. Oh, wait. Like the new node struct store thing, I went through all possible combinations of those three things without realizing there were three parts, where I had them paired this way and paired this way and paired this way before I was like, there are three independent things here. And then now I can go think about through. It's obvious. Oh, there's three things, and I line up like this, and then I can now make an intelligent decision. Maybe I will get rid of these parts and fold two out of the three together. I would probably fold struct into store, but it's not. Like I said, I've tried it in the past, but I didn't quite have it all sorted out in my head.
Yeah. Okay. Well,
cool.
That's where I'm at. So
excellent. I'm very pumped. You have excited me.
Good. I'm pretty excited about the progress is going fast. I mean, I only started this project version 2 like 3 weeks ago.
Oh wow. Yeah, okay. Yeah, you're going faster than me. I'm spending over half time on ecstasy, and it's hard to switch between the two.
I'm trying to force myself to not do the things that I want to do and just do the things that will be fast, but then try and get the things that really need to be in there in.
Yes.
So that means spending days sometimes trying to figure out what those things are and whether they need to be there.
Yeah.
So
yeah, I've burned a lot of time on the philosophy of sea of nodes, if you will, sorting out the meaning.
Yeah.
That's what it is. All right. Well, I think we're at a good break point. Anyone want to throw anything in before we call it here? All right. Until we meet again. Bye.
Bye.
See you.